So the module number 2 is physical layer. Physical layer is module number 2. In that you have the transmission media. So transmission media is located below the physical layer. Where is transmission media located? It is located below the physical layer. Directly controlled by the physical layer. Transmission media is directly controlled by the physical layer. So transmission media is located below the physical layer and it is directly controlled by the physical layer. Signals transmitted in the form of electromagnetic energy. So signals are transmitted in the form of electromagnetic energy. So under transmission media, types of transmission media, we have two types, guided media and unguided media. So guided media, you have twisted pair cables, coaxial cables, optical fiber cables, and in unguided we have radio waves, microwaves, infrared. So in our syllabus under transmission media we only will learn about the guided media. In our syllabus only guided media is covered. So let's see guided media. Guided media is also referred to as wired or bounded transmission media. Signals being transmitted are directly and confined in a narrow pathway by using physical links. So guided media is nothing but wired transmission. Features are it gives high speed, security and use of comparatively shorter distances. So when you are transmitting signals, the signals are transmitted in high speed. They are secure signals. You have this security provided to the signals and it is comparatively used for shorter distances. Types of guided media: twisted pair cables, shielded twisted pair cables and unshielded twisted pair cables. So you have coaxial cables, optical fiber cables or fiber optics cable. So twisted pair cables. So your first part is your twisted pair cables. In twisted pair you have shielded and you have unshielded. Shielded is STP and unshielded is UTP. So unshielded, they do not have this shield around them. So you can say that they are less costly, whereas STP are more costly. Why? Because they have the shield, they have a protection so that you do not get the current shock. You also have coaxial cables and optical fiber cables. So in guided media we have three types: twisted pair cables, coaxial cables and optical fiber cables. So first is twisted pair cables. A type of cable that consists of two independently insulated wires twisted around one another. So if you see this figure, you see that this is one wire, this is the second wire, and two independent wires are twisted around each other. Again, this is the first wire, this is the second wire. The wires are twisted around each other. One of the wire used to carry signal, another is a ground reference. So the one wire is for carrying the signal and the other wire is for ground reference. Receiver uses difference between two. Reduce crosstalk. Applications are telephone network from home to local exchange, within buildings, private branch exchange, for LAN. So what are the applications of twisted pair cables? They are used for telephonic network, they are used within the buildings and for LAN. Twisted pair cables. If the pair of wires are not twisted, electromagnetic noises from example motors will affect the closure wire more than the farther wire, thereby causing a error. So if the pairs are not twisted properly, then it will cause a error to the one which is closer, which is more than, will affect the closer wire more than the farther wire. So So twisted pair cable advantages are it is less expensive and easy to work with. Disadvantages: low data rate, short range. So you cannot use it for a long range. So like telephone communication, short range is there within the building. You have the intercom system. This intercom system is also using twisted pair cables. That means for a low data rate, for a short range, you want to exchange information, exchange communication, exchange signals for a short range. Then only you use the twisted pair cables. For long ranges, it won't work. Unshielded twisted pair cables. Unshielded is what? Your UTP, which was what? Which was less costly. So UTP is ordinary telephone wire. It is less expensive, weak immunity against noise and interference, suffers from external EM interference. So it suffers from interference property. It is less expensive and it is nothing but an ordinary telephonic wire. Unshielded twisted pair cable Cat3. The features of Cat3 are up to 16 MHz, voice grade found in most offices, twist length of 7.5 cm to 10 cm. For Cat4, you have a frequency of up to 20 MHz. Cat5 up to 100 MHz, commonly pre-installed in new office buildings. Twist length is 0.6 cm to 0.85 cm. So this one is there in the new office buildings because this is the latest. Cat 5e is an enhanced version, Cat 6 and Cat 7. Categories of UTP cables. Electronic Industries Association classifies UTP cables according to the quality. Category 1, the lowest quality, only good for voice, mainly found in very old buildings, not recommended now. So Cat 1 cable is something which is category 1 cable. It is not used nowadays. Category 2, good for voice and low data rates up to 4 Mbps for low speed token ring networks. Category 3, at least 3 twists per foot for up to 10 Mbps, common in phone networks in residential buildings. So category 3 is there in phone networks. Category 4 up to 16 Mbps, mainly for token rings. Category 5 or 5E. 5E is the enhanced category, up to 100 Mbps, common for networks targeted for high speed data communication. Category 6, more twist than Cat 5, up to 200 Mbps. Then category 7, this is the speed of the network. Category 7, each pair is individually wrapped in a helical metallic foil followed by metallic shield, which decreases the crosstalk and increases the data rate. So it decreases the crosstalk but increases the data rate. Next is shielded twisted pair cables, STP. The STP cables are similar to UTP cables except that they have a metal foil or braided metal mesh cover that encases each pair of insulated wire. So in case of UTP, we saw that the wires are only insulated and the wires are shielded. They are not shielded, they are just twisted and they are insulated. But in case of STP, you don't have just the insulation but you also have a foil shielding. That is what? A metal foil. An extra metal sheath on each pair. So on each of the pairs of wires we have an extra metal foil. Relatively, it is more expensive as compared to the UTP wires. Provide better performance than UTP, increased data rate, increased bandwidth. UTP versus STP, unshielded twisted pair, ordinary telephone wire. It is cheapest, easiest to install, suffers from EM interference. STP, metal braid or sheathing that reduces interference. More expensive, easiest to install and harder to handle. So UTP versus the STP. RJ45 is a standard connector are used for twisted pair cables. So this is a connector. This is used for twisted pair cable. So in this connector, if you see this part, then you can see either UTP will be written or STP will be written. Next is your coaxial cables. Coaxial cables, plastic cover, outer conductor shield, inner conductor, and you have a insulator. Coaxial cable, it consists of solid wire core surrounded by one or more foil or wire shield, each separated by some kind of plastic insulator. The inner core carries the signals and the outer shield provides the ground. The coaxial cable has a high electric properties and is suitable for high speed communication. It is used in television signals. In general, coaxial cable or coax carry signals of high frequency 100 kHz to 500 MHz than the UTP cables. So coaxial cables, they are more better version of the UTP cables because they are carrying high frequency signals. Outer metallic wrapping serves both as a shield against noise and as a second conductor that completes the circuit. Versatile transmission media used in wide variety of applications including telephone distribution, aerial to TV systems. So this is your application of coaxial cables. Coaxial cable advantages better than twisted pair cables. Used as shared cable network, used for broad band transmission and higher bandwidth up to 400 Mbps. So it is higher bandwidth up to 400 Mbps. That much speed is provided by these cables. Disadvantages: expensive compared to the twisted pair cables because it is providing you high frequency, high speed. Also it is providing a shield. So it is expensive as compared to the twisted pair cables. Coaxial cables are not compatible with the twisted pair cables. BNC connectors. BNC connectors are used for connecting the coaxial cables together at connecting points when repeaters are required. So RJ45 is used as a connector for twisted pair cable, whereas BNC is used as a connector for coaxial cable. Coaxial cable standards: RJ8 thick Ethernet, RJ9 thick Ethernet, RJ11 thin Ethernet, RJ58 thin Ethernet, RJ59 is TV. Next type of guided transmission media, that is a third type, is fiber optics. So fiber optics, fiber has a core and a cladding. The density of core and cladding are different. You have a buffer area and a outer jacket. Fiber optics. Fiber optic cable is known as the most sophisticated cables used in long distance network connections. Data transmission is done in the form of light rays rather than electrical signals. So we saw that in the first two types, that is in the twisted pair cables, twisted pair cables and coaxial cables, data was transmitted. Data transmission is done in form of electrical signals. But in case of optical fiber optics, optic meaning light, fiber meaning done with the help of fiber. Fiber consists of a core and a cladding. So you have the fiber optics. So light rays are used for data transmission. Common light sources are LEDs and lasers. LEDs are nothing but light emitting diodes and laser light. It has an inner core of glass that conducts light. The inner core is surrounded by cladding. Cladding is nothing but a layer of glass material that reflects light back into the core. So your inner part is the cladding and the outer part is your core. Inner core is surrounded by the cladding. So this is my core and this is my cladding. Each fiber is surrounded by a plastic sheath. Fiber optics, infrared light is transmitted through fiber and confined due to total internal reflection. Fibers can be made out of either plastic or glass, used for high-speed backbones and pipes over long distances. Comparatively, it is expensive. So this is fiber optic transmission. You have step index multimode, graded index multimode and a single mode transmission. Next is an optical fiber consists of a core, denser material and the cladding, less dense material. Simplest one is a multimode step index optical fiber. Multimode is multiple paths, whereas step index is equal to the refractive index, follows a step function profile, that is an abrupt change of refractive index between the core and the cladding. Light bounces back and forth along the core. So what are the fiber optic cable advantages? It is lightweight, immune to electrical and magnetic interference, highly suitable for long distance and electrical environments, secure transmission, resistance to corrosive materials, used for broadband transmission. Disadvantages are installation and maintenance is difficult. Connecting two fibers together is a difficult process because of noise immunity. They are virtually impossible to tap. Propagation of light is unidirectional and it is most expensive. Why it is expensive? Because it is using the fiber network which is consisting of core and cladding and it is using the light waves or the light rays. So the construction of fiber optic cable is expensive and transmission is very fast.